Hello everyone, my name is İlmay Taş. I am a second semester computer science student at Bilkent University, and today I will be presenting my Physics 102 project titled Observing the Hall Voltage. Firstly, I want to mention about the project's aim. This project aims to explore the relationships between Hall voltage, electric current, and magnetic fields utilizing the formula VH equals B times I times RH. The experiment is divided into two main parts. First of all, studying the relationship between Hall voltage and electric current while keeping the magnetic field constant. And the second part is that investigating the relationship between Hall voltage and magnetic field while keeping the electric current constant. And now I introduce you the equipments. For this experiment, I used an adjustable Hall measurement device with a resistance of 50.58 kilo ohm, which allowed me to control the magnetic field by varying the distance between the magnets. A measuring ruler was used to accurately determine these distances. Additionally, I utilized a DC power source, a digital multimeter on the left to measure the Hall voltage, another multimeter on the right to display the DC voltage, a gauge meter to measure the magnetic field strength, and a set of cables to complete the necessary connections. And this is my experimental setup. The first stage is constant magnetic field stage. I varied the current using the DC power source and measured the corresponding Hall voltage with the multimeter. The relationship was analyzed using the formula VH equals B times I times RH. For the first part, I set the Hall measurement device to 1.5 cm, and while this was happening, I measured 1.505 kilogauss with the gauge meter, and I used this value. By decreasing the voltage values from 24 volts to 4 volts, in 4 intervals, I stated that the resistance of the device was 50.58 kilo ohm and calculated the Hall voltage. The Hall voltage increased linearly with the current at a constant magnetic field. Using the graph slope and the Hall coefficient, the theoretical magnetic field was calculated as 5.544 kilogauss. The error was high, mainly due to fluctuations in gauge meter readings and external noise. Considering these factors, I even expected a larger error. The second stage is a constant current stage. To study the relationship between Hall voltage and magnetic fields, I set the DC power supply to 20 volts and I kept the current constant at 0.4 milliampere. Adjusting the distance of the Hall voltage device varied the magnetic field. For each distance setting, I measured the Hall voltage and I recorded it. This data was analyzed using the same formula which predicts a linear relationship. These are my data, and the graph shows a near linear relationship between Hall voltage and magnetic fields, yet errors likely occurred due to fluctuations in the gauge meter readings, which caused deviations from the expected values, but I think overall my experiment was successful.